Now we go to the example 7. We go through the questions in the figure. ABC and ADE are straight lines. So ADE and the ABC are both straight lines. And the BC is equal to BD. So BC is equal to BD. So by this sentence, we know that the triangle BCD is an isosceles triangle. And by knowing that, actually, we know that the base angle must be equal, so that angle BCD must be equal to angle BDC. Okay, so actually we can first write this down. Angle BDC will be equal to angle BCD. Okay, but is that we can use this one? We don't know yet. Okay, then we go through the question. An angle ACD is equal to 63 degrees. That is what we used. And last one is the angle CDE is equal to 90 degrees. This one. Okay. So now we go to the part A. We need to find the angle theta. So that actually, after we found that angle BDC is equal to angle BCD, we can see that the angle theta here and the angle BDC, and also lastly the angle CDE are all on the straight line. So the sum of them should be equal to 180 degrees. The reason is angles on a straight line. Secondly, as what we write here, we know that these two angles are equal, so we write this down. Angle BDC is equal to angle BCD. The reason is the base angles of isosceles triangle. So it should be equal to 63 degrees. And after we know that it is 63 degrees, we can substitute this one into the first equation, so that theta plus 63 degrees plus 90 degrees is equal to 180. So lastly, we can find that theta would be equal to 27 degrees. That is part A. Then now we go to part B. So before we discuss how to do the part B, we need to clean up the part A first. In the part A, we found that theta is equal to 27 degrees. And it is a very good habit that we locate this one back into the graph, that theta is 27 degrees. And we also found this one is 63 degrees, right? So in the part B, it asks that is triangle ABD an isosceles triangle. Which one is triangle ABD? It's good for us to locate it. That is this triangle in the blue color. Okay, that is ABD. So if we want to prove that it is an isosceles triangle, it is very important that we need to find the base angles of this triangle, whether they are equal. If the base angles of this triangle is equal, then it must be an isosceles triangle. So now we need to find the values of the interior angles of this triangle. The first one we found, that is what we found in the A, that's the theta is equal to 27 degrees. And the second angle we can find actually is this one, is the angle BAD. Why? Actually, the angle BAD, okay, it also an angle in the triangle CDA. Okay, so we locate this one, triangle ACD. Okay, we can see that the angle CDA actually we found is 90 degrees. That is shown in part A, and the angle ACD is equal to 63 degrees. So by the angle sum of triangle, actually angle CAD is equal to 180 degrees minus 90 degrees minus 63 degrees. That is angle sum of triangle. Okay, so we can find that actually angle CAD is also equal to 27 degrees. So after we found that, we can see that it's equal to theta. That's what we found in A. So actually it is an isosceles triangle. So we can write this conclusion down here as the angle CAD is equal to theta is equal to 27 degrees. Therefore, triangle ABD is an isosceles triangle. And the reason we know is that opposite sides the base angles equal. That's it.